Alright everyone, so this is the second lesson and also the last lesson for topic 8 differential equation. So if you can recall in the previous lesson, you already understand what is the definition of differential equations, right? So meaning that you know that any equation with the term of dy dx or d square y dx square is called as differential equation. Then after that, you also learn how to solve a differential equation, meaning how to find a general solution and also the particular solution for a differential equation. So it involves the technique of how do you separate the variable that you have in your equation to have y and dy dx at one side and then x at the other side, then differentiate it, integrate it with respect to x. Okay, so for today's lesson, we are going to put what we have learned previously into a real life context. So meaning instead of the differential equation is given by the questions, we are going to formulate a simple statement, meaning that we need to form the differential equation by ourselves based on the situation given. Okay, so the second one is how do you interpret the solution of a differential equation. So basically you'll be able to see the whole idea of differential equation, meaning that you are given a situation, then you need to form a differential equation based on the situation given, then you need to solve it, meaning that use the technique or use the knowledge, the skill that you have learned previously. Then after that, you also need to understand how do you interpret the solution based on the context given. Okay, so that's the learning outcome for the day. Alright, so let's start with the introduction. Alright, so as what I said, so in this lesson, we are going to do some modeling with a differential equation. So meaning how do you set up a simple differential equation, then you use the equation to find the general and the particular solution. Okay, so for us to interpret the information given in the situation, what we try to do is we need to understand some of the keywords. Okay, so before we move on to like the example, so let's try to go through like this simple idea first. Okay, so the first one, I think all of you already knew this as well. So how do we actually interpret the idea of rate of increase of x with respect to y? How do you actually express this in terms of mathematics? Yeah, so rate of change of y with respect to x, with respect to time. So let's say we try to put our time as t. So meaning that you will try to do dx dt. Okay. So from what we have learned previously in P1, you should understand that. So like for example, when we say dy dx is equal to gradient, right? That is because of dy dx stand for the rate of increase of y or rate of decrease lah. So basically the rate of change of y with respect to x. So that's why it's the definition of gradient. So that's why dy dx equals to gradient. So meaning like the definition wise is the same. Okay, so now in this chapter, you are going to look at a lot of words like proportionality. So how do we actually express rate of increase of x is proportional to y? Okay, so we know that, I think you learned this in your chemistry as well. So rate of increase or rate of change of x, you will try to write dx dt, right? So proportional to y, so that's a symbol represent proportional in max, which is something like an alpha. So it's proportional to y. Okay, so how do we actually write this in equation? So what is the meaning of proportional? Proportional meaning that if let's say my when my y equals to 2, then my dx dt may be equals to 6. So if let's say if my y now increases to 4, then what is my dx dt? Then you know that it's going to be double as well, right? So it becomes 12. So what you can realize is that it's a variable that always connect them together. So like how do you get 6 from 2? You multiply 3. Same thing, how do you get 12 from 4? You multiply by 3. So that's why when we try to rewrite this in a form of equation, then we'll try to write it in such a way that dx dt equal to a constant multiplied by y. Okay, so k is like a constant, so it doesn't have to be always integer. It can be like a decimal or even a fraction. Okay, so the same thing. What about rate of increase of x is inversely proportional to y? So we'll try to write it in a way dx dt, okay, is inversely proportional. How do you say inversely proportional? So instead of y, so we will try to put 1 over y. Okay, so this is inversely proportional. So it's the same thing. If it's inversely proportional, there is a variable that always connect them together as well. So that's why we write dx dt will be equals to k over y. Okay, so just make sure that always at the coefficient part you try to put an variable. Alright, so which is like the k represented by a constant k in this case. Okay, so that's the idea. So now we'll be looking at like 5 examples. So hopefully from the example itself you will learn how to interpret and how do you find out some important information for you to uh set up the simple differential equation, then after that solve it. Okay, so let's look at example 1. Yeah, so you are encouraged to just read through the questions first before you move on to answer the questions. Okay, yeah, so velocity is defined to be the rate of change of displacement. So every time when I try to read the question, then I'll try to interpret in a mathematical context first. So velocity is defined to be the rate of change of displacement with respect to time. Okay, so in this case, they try to use displacement s, so we try to write it in a max form first. So velocity v is defined to be the rate of change of displacement with respect to time. So that's why v equals to ds dt. Okay, so that's the first thing that I have. Then the next one, the velocity of a particle at time t seconds is inversely proportional to its displacement s from an origin. So what does that mean? So meaning that the velocity is actually inversely proportional to the displacement, which is 1 over s. Alright, so I think at this part it's still quite easy. Velocity v inversely proportional, so meaning 1 over s lah. Alright, so now we move on to A. So we need to form a differential equation to represent this data. So how do we write that? So this data, right? So meaning this is the data that we have. So V is inversely proportional to S. So what is V? V is ds dt, right? Okay, and remember how do we change this back into equation? So equal to K, a constant, over S. Is that okay? Yeah, so there's no more information given in this question. So that's why your A, your answer is just like that. So ds dt equals to K over S. So K is just a constant. Okay, so B, and let's move on. So initially the particle has a displacement of 2 meters from M after 1 second. So yeah, we can write down this first. So initially the particle has a displacement of 2 meters from O. What is the meaning of initially? So initially meaning that at the time when you start this experiment. So meaning that our T is equal to 0. So when your T is equals to 0, then we have a displacement S equals to 2. Okay? Then the second one, after 1 second, the particle has a displacement of 5 meters from O. So meaning that when your time equals to 1, the displacement is 5. Okay, so this is the two information that we have. So now the question asks us to solve the differential equation and give your answer in the form of t equals to f of x. Okay, so let's try to use what we have. So the differential equation is ds dt equal to k over s, right? So now we can start to do the so-called integration. So we move over the s to the front part. Okay, integrate with respect to t for both sides. and you will be able to get integrate x dx and integrate k dt. Okay, so s ds, it will become x squared over 2 equal to kt plus c. Alright, so after you have get the general solution, then now we can try to do some substitution, right? So let's start with t equals to 0 first. So when t equals to 0, s equals to 2. Then now we can substitute. So you have 2 square over 2 equal to k times 0 plus c. So from here you can get your first constant c equal to 2. Alright, so now we can move on to the second part. Yeah, so don't forget you still have a k here. So that's why we need to use the second information that we have found just now, which is t equals to 1 and s equal to 5. So now let's substitute again. So 5 square over 2 equal to k multiply with 1. So the c that we have got is 2, right? Okay, so now you should be able to get k equals to 25 over 2 minus 2, which gives you 21 over 2. Okay, so we need to rewrite it. So you have s squared over 2 equal to, your k is 21 over 2, t constant 2. Okay, so now you need to express it in the way of t equals to f of s, right? So we need to rearrange the whole thing. So maybe multiply first. So you have s squared equals to 21t plus 4. Okay, and then move on. So you 21t equal to s squared minus 4. So you only want t only, so that's why t equals to s squared minus 4 over 21. And that will be your answer for B. Alright, so now move on to C. So for C, find t when the displacement from the particle from O is 10 meters. Okay, so maybe let me just try to answer it here. So this is the part for C. Yeah, it's quite a short one. So you already get the equation, right? So now we can use this equation to help us to solve C. So find t when the displacement is 10. So meaning that you want to know when s equal to 10, what is your t? So what we try to do, substitute back into the equation that we have. So since t equal to s squared minus 4 over 21, right? So that's why we just substitute the s as 10 minus 4 over 21. Then you should be able to get your answer, 4.57 seconds. Okay, is that all right? Yeah. So how do we know that you're supposed to give second instead of like minute, hour, and so on? Because from this question, they give you that after 1 second, the displacement is 5. Then initially is yeah, after 1 second. So that's why it will be always in the unit of second. Yeah. I mean, of course, the most obvious one is here lah. So they try to write at time t second. Okay, so that's why our t is referred to second. Okay, so later you'll be looking at some questions that the t is referred to, maybe like a month or like a day and so on. Okay, all right, so move on to number 2. Okay, number 2, in a chemical reaction, a substance X reacts with another substance Y. Okay, so the masses of substances Y and X and Y after time t second are X and Y grams respectively. Okay, so meaning that our X and Y stand for the masses now, and it's in unit of gram. So our time is t and it's in unit of seconds. So it's given that dy dt equal to negative 0.5 xy, and then the other information given is x equals to 20t, negative 2t, and then we also know that t equals to 0 and y equal to 50. Okay, so now the question wants us to form a differential equation in y and t. Alright, so let's try to do this. So A, So you already have dy dt, right? So we start from there. So dy dt equal to negative 0.5 xy. So the questions want the differential equation in terms of y and t only, so meaning we should substitute something with the x here. So from the question, we also know that x equals to 20 e power of negative 2t, right? So we should always substitute that expression. So negative 0.5 multiply 20 e negative 2t multiplied by y. Okay, so you just try to simplify it, then you will be able to get negative 10y e negative 2t. All right, so that will be your answer for A. Yeah, you can't do any, I mean, you don't need to do anything else because it's just from a differential equation. So now you have in the terms of y and t already, right? So that's it. Okay, so B, solve this equation to obtain an expression of y in terms of t. So you know that you need to find the particular solution already. Okay, so now I think you can try to move on by your own. Yeah, so I mean what is important in this lesson is just that you know how to extract all the important information, and in the working itself you need to apply what you have learned previously. All right, so now you can try to, I mean, try it by your own as well. How do you find the solution for this? So dy dt equal to negative 10 y negative 2t. Okay, so we try to move it around. So you have 1 over y dy dt equal to negative 10 negative 2t. So the integration with respect to t. Okay, so yeah, I encourage you to try it at your own also for this part. Then you can try to watch this as like 2 times speed when you try to check your answer. Okay, so we move on. So you have ln y, okay, equal to negative 10. So this is the part where you can integrate, right? So e power negative 2, so you get negative 1 over 2e negative 2t. And let's see. All right, so ln y equal to, so times you get 5e negative 2t plus c. All right, so you might have a questions that, I mean, do you try to put the c inside here, then you multiply and you get negative 10c or not? So the idea is every variable that you try to put, right? I mean, maybe someone that I mean, maybe some of you might want to do negative 10c, or some of you think that when you multiply by negative 10c, you are still get a constant. So it depends on your equation. Then, I mean, after that, maybe the c that you solve can be different. But when you try to substitute back into the equation, it will be just based on your equation and you get the exactly same value with your friend's one. Okay, so don't worry about like whether you expand then or not. So if you want to expand, then yes, then you just leave negative 10c, and when you try to solve it, then you substitute c back into the equation that you are referring to. Okay, so now same thing, we will need to find out our c here. So in this question is already given just now that when t equals to 0, y equals to 50, right? Okay, so now we can do the substitution. So ln 0 equal to 5, ln 50 equal to 5e negative 2 times 0 plus c. Okay, so e power 0 gives us 1. So that's why I have c equal to ln 50 minus 5. Okay, so make sure ln 50 stand by itself. It's not ln 50. You are not ln the whole thing for 50 minus 5. It's ln 50 then minus 5. Okay, so now we try to put it back into the equation that we have. So ln y equal to 5e negative 2t plus c, so plus ln 50 and then minus 5. Okay, So same thing, we need to rearrange it. So try to express it in y. Yeah, obtain an expression for y in terms of t. So that's why your answer should be given in the form of y equals to what. So e, yeah, we try to change it into e, or you can combine the ln first. I think that would be easier. So ln y minus ln 50 equal to 5. Maybe we can try to do some simplification, factorization over here. So you have 5e negative 2t minus 1. Okay, so for this, you have ln y over 50 equal to 5e negative 2t minus 1. Alright, so y over 50 gives you e power 5e minus 2t minus 1, and then y equal to multiply the whole thing by 50. Okay, so you just leave your answer in this case. Alright, so that will be your answer. Okay, so now let's try to look at C. So for C, find the mass of y that remains as t gets very large. Okay, so now we have y equals to 50. So you can write down your equation first. Y equal to 50 e, 50 e power 5 e minus 2t minus 1. Okay, so can you try to imagine? So now we say that when t gets very large, so what does that mean? Meaning that your t will be approaching to infinity. Yeah, that's the idea, right? Gets very large. So meaning that t is increases and getting nearer and nearer to infinity. Okay, so now we will start with this part. So you have exponential negative 2t, right? So meaning that, can you imagine when you have e that approaching to negative infinity, what is your number? Yeah, so you can try to recall the graph of the exponential graph. Okay, so a very quick one, you should remember that your exponential graph looks like this, right? So it would just go up like this. Okay, so it's the intersect is like 1 here. So you can see that when your e, so when you move on to continue to draw this part towards your negative side for your x-axis, you'll realize that if let's say this is the x and this is your y, meaning your e power x, then you know that when your x is approaches to negative infinity, okay, so meaning that it continue to move on like from negative 5, negative 10, negative 15, 20, and you continue to move on, what can you see? So the line here will actually keep on getting nearer and nearer to 0, right? So that's why when x approaching to negative t, your e power x is actually approaching to 0. Okay, so the same thing lah. I mean, if you try to write it in such a way that x approaching to infinity, then your e negative x will actually, your e negative x will actually approaching to 0. They means the same. Okay, so if you kind of like forget how to do this, then maybe you want to write it down in your notes. Okay, or you can just check with your calculator. You press like negative e negative 5, e negative 10, e negative 20, e negative 50. So when your negative value gets larger and larger, actually the value is approaching to 0. Okay, so this is what we have learned previously. So I hope that you still remember. So yeah, you can just try out with your calculator lah. Just put your value become bigger and bigger in terms of negative. So now imagine if let's say I try to e negative 2t minus 1, right? So if the exponential part is approaching to 0, when I minus 1, then this value will be approaching to negative 1, correct? So if this is very near to 0, then when I minus 1, then it will be very near to negative 1 lah. So continue with multiply by 5, right? So when I multiply by 5, then what do I get? Then negative 1 will need to multiply by 5 as well. So it becomes negative 5. Okay, so now we need to put everything in terms of exponential now. So 50e, 5e, negative 2t minus 1, it will be approaching to 1. So you can imagine that the whole index here is approaching to negative 5. So that's why 50e, negative 5. Okay, so meaning that when t gets larger, the mass of y, okay, yeah, you can understand, right? The y equals to this. So meaning if the whole thing here is approaching to this, then the mass of y is approaching to that also lah. So when t gets larger, the mass of y remains at 50e, negative 5 grams in long run. Okay, sorry, grams. All right, so that's the idea. Okay, so yeah, you need to be very familiar with this because you look at quite a lot of questions like this, or like the divide by exponential one also. Okay, or like e negative. So you will have this kind of question in your past year paper as well. Okay, so let us move on to number 3. Okay, number 3, the value V of a motorbike as it gets older can be modeled as a continuous variable. A model is suggested to estimate the rate of decrease of the value of the motorbike. So this model is that the value V when the motorbike is T months old decreases at a rate it proportional to T. Okay, so in another words, it means that the rate of decrease of the motorbike is proportional to V. So that's why from this sentence, you'll be able to get your first information, which is dV dt. Okay, the rate of decrease of T is proportional to V. Okay, so that's the idea. So let's look at A. So write down a differential equation that is satisfied by V. So what do you have here? So your dV dt will be equal to kV. Okay, so you might have a question here. So since that is written for decreases, right? So can we try to put negative? Yes, you can. So you just equal to negative t and you state that your k is positive lah. Alright, so meaning that we try to foresee that we are going to get a negative constant already. So instead of like we write kv, then k is negative, we try to write negative kv, which k is positive. All right, so I mean there's no wrong also if you try to write kv, but then at the end of it, then you should know that when your k if you write kv, then k should be a negative constant lah. Yeah, all right, so it will be much more easier when we try to set the k as a positive constant. So when you try to find that you are dealing with a positive number, and when you read through the question, right, you can see that the B, they try to solve this in a differential equation, and when your k is a positive constant. So that's why when we try to answer A, we try to follow what we need to do at B. So that's why we just try to put k is positive constant by putting a negative kv. Okay, I hope that you understand why is that negative, because the value is actually decreases over the time. So that's why it's negative. All right, so B, the motorbike had a value of 10,000 when it was new. So what does that mean? Meaning that when the time is 0 months old, so meaning when the bike is 0 months old, meaning the motorbike is new lah. So when the motorbike is new, the value is 10,000. Okay, so solve the differential equations showing that V equals to 10,000 e power negative kt, where k is a positive constant. So we need to solve the differential equation again. So dv dt equal to negative kv. So same thing for this part, you can always try to do it by yourself also. So 1 over v dv dt equal to negative k. So integrate both sides with respect to t. Okay, then start to simplify it. So 1 over v with respect to v, negative k with respect to t. Okay, so 1 over v, then you have ln v, right? So for this part, you have negative kt plus c. Okay, so do not confuse with the k and c here. So meaning you have two variables that you need to solve basically. Okay, so after you have found this, then you can continue by substituting the information that you have here. Alright, so t equals to 0, v equals to 10,000. So now let us try to do substitution. So ln 10,000 is equal to, so negative k multiplied with 0, then you get c. So meaning your c is just ln 10,000. Alright, so now let us try to rewrite it back to the equation. So we have ln v equal to negative kt plus ln 10,000, right? Okay, so you will realize that you still have a constant k here which you didn't solve yet, but you should realize that in this question, they only give you one information which allows you to find c, and when you look back to the question, right, the equation that they want you to solve is actually in terms of k and t as well. So that's why you can leave your k there. So now we just continue to move on from there. So v will be equal to e negative kt plus ln 10,000. So let's try to split it. Then you have e ln 10,000 multiply with e k t. Alright, so the front part can be simplified as 10,000, then e negative kt. So this is what you need to show, and that's it. Alright, so shown. Okay, so you yeah, so it's given like this lah. So it's the same thing as well. If you see that if your a, right, you are not doing negative kt, if you are doing kv, it's totally fine. So you just solve for kv, and then when you reach the end, right, you will realize that you should realize that you will get like 10,000 e positive kt. Then after that, then you just based on the question, then you write that since it's given k is a positive constant, so that's why you will just change the positive k into negative k. Okay, so that's it. So now let's try to look at c. Alright, so from the questions, after 3 years, the motorbike has lost half of its value when new. So find the value of motorbike when it was 2 years old. Okay, so you can write down first the information that is given. After 3 years, the motorbike has lost half of its value. So after 3 years, meaning t equals to what? So in this question, it's given that the t is in terms of like months old, right? So that's why 3 years, meaning that your t will be equals to 36. So when t equals to 36, then v is half of the initial value, right? So initial value is 10,000. So meaning your current v now after 3 years is 5,000. Okay, so you want to find out what is the value of the motorbike when it was 2 years old, meaning that you want to get when t equals to 24, what is your v? Alright, so let's substitute into the equation that we have found just now first. Okay, so you have v equal to 10,000 e negative kt, right? Okay, so now by the first information, we should be able to get t. Then after that, we can get a complete equation. Then you should be able to find out what is your v when t equals to 24. So your v is 5,000 when the t is equal to 36. Okay, so meaning that you have 5,000 equal to 10,000. Maybe you can straight away divide here. So 5,000 divided by 10,000, you have 1 over 2, right? Then after that, e negative 36k. Okay, So for you to solve the k here, meaning you need to change it into ln, right? So ln 1 over 2 equal to negative 36k. Okay, so you know that ln 1 over 2, how can this be changed? So ln over 2 is equal to negative ln 2, right? Then equal to negative 36k. So from here, we can try to eliminate the negative. So you know that 36k will be equal to ln 2. Okay, so k is actually equal to ln 2 over 36. Alright, yeah, I hope that you still remember here. So from here to here, it's like when you have ln a over b, you can always rewrite it in the form of negative ln b over a, meaning when you try to upside down the fraction that you have for ln, then you put a negative. Alright, because the idea is b over a is the power of negative 1, so you bring down the negative, then it becomes like negative ln b over a lah. Okay, so now you have obtained the complete equation here, which gives you v equal to 10,000 e negative ln 2 over 36k. Okay, so now we continue to find the v that we want. So t equals to 24, right? So we do substitution. So v equals to 10,000 e negative ln 2 over 36 multiplied by 24. Okay, so what can you get from here? So equal to 10,000 e. So you have negative 2 ln 2 over 3. Okay, so at this point, you can just check with your calculator lah, and you should be able to get 26299.91, which when we try to change it into 3 significant figure, then it gives us 6300 in 3 significant figure. Okay, all right, so that's it for this question 3. Okay, so yeah, so I think that the idea is actually quite easy. So what you need to do is you need to understand the terms given in the question. Then the rest is just like the prior knowledge that you have learned previously already. Okay, so move on to 4. Alright, number 4. The spread of a disease occurs at a rate proportional to the product of the number of people infected and number not infected. Initially, 50 out of the population of 1,050 are infected and the disease is spreading at a rate of 10 new cases per day. So if n is the number infected after t days, show that the NDT is equals to this expression. So you can see that there are different terms used in these questions. You can see spread of disease, number of people infected, number not infected, and then n is number infected. So do they mean the same thing? So you see, when we talk about n is number infected, right? Is it the same when we talk about the disease is being spread out? So the disease spread out, then only you have people that get infected, right? So meaning they are talking about the same thing. So the spread of a disease occurs at a rate, meaning that the rate of the increase for the spread of the disease, right? So meaning that we are trying to write it in the form of dn dt. Okay, we are talking about how the spread of disease increases over the time, right? So that's why dn dt is at a rate proportional to the product. So it's proportional to the product of number of people infected. So number of people getting infected is n, right? So it's proportional to n, the product of number of people infected and number not infected. So if n is the number of people get infected, what is the number that not infected? So meaning that you should know what is the population of the what is the population there. Then after that, you use the total number, you minus the number that get infected, right? So in this case, the population is 1,050. So that's why 1,050 minus n. Okay, so meaning n is the number of people getting infected, 1,050 minus n is the number of not infected. So you use the total to minus the one that get infected, then you get the non-infected lah. Alright, so that's the first thing that we can get. Then the second one, initially. So when we look at the words initially, then you should know that it's referred to t equals to 0. Okay, so initially 50 out of a population of 1,550 are infected. So meaning that when t equals to 0, initially there are 50 people that get infected. Alright, so t equals to 0, n equals to 50. And the disease is spreading at a rate of 10 new cases per day. So meaning that your dn dt, the rate of change of the number of people get infected, is actually equals to 10. Okay, you might wonder, like, you have this equation here, then what for the 10 here? So it's actually is the number that after you substitute 0 inside. So meaning that for n equals to 50 and dn dt is equals to 10 is referring to when initially, or when your time is equals to 0, which in this case is at 0 day when you start your investigation. All right, so now let's start with A. So if n is the number of people infected, show that the n dt equals to this. So now we need to start from the expression that we have written just now. So dn dt will be equal to, so what do we need to do? We need to add a constant, right? So equal to kn multiply with 1,050 minus n. Okay, so now you need to express it in this term, right? And you should realize that there's one thing different here, which is you only have the term of n, but then here you have k. So how can you actually solve for k? Then you need to use the information given here. So you know that when t equals to 0, dn dt is 10, right? So that's why we can substitute dn dt as 10. Then we want to find k. So what is the n? The n is 50, right? Correct? When the t is equals to 0. So that's why 50 and 1,050 minus n, which is 50. Okay? So you must make sure that they are happen at the same timeline, then only you can substitute at 1. So meaning that when you try to substitute x and y, then you must make sure that it's on the same point, then you only can do that. So we know that n equals to 15, dn dt equals to 10. They all happen at the same time, which is t equals to 0. Then only you can substitute these two values at the same time and you can get k. Okay, so let's try to solve it. So you have k equal to, so 50 multiply with 1,000 here, which gives you like 50,000. So 50,000 k. So when you find your k, then it will be equal to 1 over 5,000. Alright, so now we put it back into the equation. So dn dt will be equals to 1 over 5,000. I think we can straight away write it. So yeah, it's okay. 1 over 5,000, then multiply with n and multiply with 1050 minus n. Okay, so we rewrite the whole thing and put it in the numerator as given in the questions here. So we have n multiply with 1,050 minus n over 5,000. Okay, which you proved. Alright, so that's it for number 8. Yeah, so you can see we proved it already. Alright, so let's see B. So solve this differential equation to find the number of people infected after t days. So this one is solving differential equations. Okay, so same thing, I recommend you to try this out by yourself. So when you try to do this, you should realize that it's very similar to the last example that we have actually completed in our first handout. Okay, so you might want to referring to that and then try it out your own. Yeah, correct. This is the the one that with the very long working. Okay, so let's try to copy the equation first. Okay, same thing. We try to move the n terms over the other side. So you have 1 over n, 1050 minus n, and then dn dt equal to 1 over 5,000. Okay, so now we can start to do the integration. With respect to t. Same thing to the right hand side. Okay, so can you try this out by yourself? Yeah, so I'm going to like write it down. Yeah, because I think you should able to actually do this already, right? By referring to the last example. So I'm just going to write down the working. Then after you have tried it, then you check your answer here. Okay, so you should able to solve it by yourself by partial fractions, right? So it's the same thing. Then after that, you solve it up to this point. Then let's try to do the substitution. So when t equals to 0, the n is equal to 50. So you have ln 50 over 1050 minus 50, 0.210 plus c, which gives you c equals to ln 50 over 1000, okay, which gives you 0.05 plus. So we can straight away write down the answer here. All right, so after you have get the c, then let's continue to move on. Yeah, put it back to the equation. So ln n over 1050 minus n equal to 0.21t plus ln 0.05. Is that okay? So when you reach this step, then you should able to find out the e. So n over 1050 minus n equal to e. Okay, so 0.21t plus ln 0.05. Okay, now same thing, we need to rearrange it. So n over 1050 minus n, okay, which will give you e ln 0.05 multiply with e 0.21t, which will give you n over 1050 minus n 0.05 e 0.21t. Okay, then you remember how do you want to express it in terms of n, then you need move the whole thing to the back, right? So you have n equal to 52.5 e 0.21t minus 0.05 and e 0.21t. Okay, so if you want to leave your answer with no, so you know 52.5 is like 52, then 1 over 2, so this is 1 over 20. So what you can try to do is you can try to multiply the whole thing with 20, then you do not have like all the fraction here lah. So like 20n equal to 1050e 0.21t minus 1, meaning n here 0.21t. Okay, so you move it in front, then you left with 20n plus n e 0.21t equals to 1050 e 0.21t. So factorize, okay, then you move. Okay, and you will be able to get 20 plus n e, sorry, no n already, 20 plus e 0.21t. Okay, is that all right? Yeah. Okay, so we move on to number C. So it's the same thing if you get something like 52.5 here, then 1, then 0.05. Yeah, but it's just that if we try to write it in like fraction, then you have fraction over fraction lah. So it's easier for us to just multiply everything with 20. But then if let's say in the steps above, right, what you try to do is the 1 over 5,000, you move it to, I mean, instead of like bringing only 1 over n, then if you bring the 5,000 over here also, then you will straight away get the last part here, which you do not need to multiply 20 anymore, but they just mean the same thing. Yeah, okay, I think that you can understand it. Okay, so that's the answer for B. So now move on to C. So how long will it take for 250 people to be infected? So meaning that you have your N, meaning number of cases is 250, and you want to find out your T. Okay, so meaning N equal to 250, and you want to find out what is the time that need to reach 250. So you just substitute 1050E 0.21T over 20 plus E 0.21T. Okay, same thing, you multiply back in front. So you have 5,000 plus 250E 0.21T equal to 1050E 0.21T. Okay, so bring this over here, then you have 800 equal to 5,000. Okay, so E 0.21T equal to 5, so 50 over 8, which means 25 over 4. Alright, then you can continue to solve it. So you have, yeah, do it in ln lah. So T will be equal to, so you imagine you are ln this, so ln 25 over 4, right? Then after that you have a 0.21, so divide by 0.21, and you should able to get 8.73 days. Okay, so make sure that you are referring to the questions because the question are writing your N in terms of like N is the number infected after T days. So that's why your T that you have obtained here, it should be in the unit of days. Okay, so let's try to look at D. Okay, so for D, explain why everyone in the population will eventually be infected. So meaning that you need to explain that in the long run, the N will always become the whole population, which is 1050. I mean, in theoretically lah, okay? So now let's try to see how to explain this. So you see that you have your N here, right? So let us try to write down the equation first. So you have N equal to 1050E 0.21T, and then 20 plus E 0.21T. Okay, so meaning that they want you to explain like why the whole population will eventually get infected. So meaning that in the long run. So in the long run, meaning that what does that mean? It means that when your T is approaching to infinity. So meaning that like 1 day, 2 day, 3 day, 4 day, then up to infinity day. Okay, so meaning at time passes by, eventually your N will become 1050. So how do you prove that? So you remember just now what we try to do is so you know the graph for your exponential look like this, right? Okay, so you know that when your E goes to positive infinity, the E infinity will go to infinity as well, correct? So when if let's say this is your X, this is your EX, so when your X is approaching to infinity, your EX will be approaching to infinity as well. But when X approaching to negative infinity, so meaning that to the left hand side, then your EX is approaching to 0, right? Okay, so for this case, I mean, of course, we can't prove that your N will become infinity lah. So we need to prove that it will be at 1050. So how do we do that? So you can see that for the E that we have here is like positive. So what we need to do is we need to change it to negative. So instead of solving like 2 exponential here, what we try to do is we try to divide everything. Okay, so you can imagine when I try to divide every term by E 0.21T, what do I get? So I get N equal to So imagine this part, when I divide, then I only left with 1050, right? So how about the denominator? So 20 divided by e 0.21t, then I get 20e negative 0.21t, right? It's like 20 over e 0.21t. So I bring this up, then it becomes negative, right? Okay, then after that, for the last part, when you try to divide, then you left with only 1, right? So plus 1. So now this is the equation that we have. So now we try to solve it like one by one. So you see, you have your t approaching to infinity, right? So when your t is towards infinity, so what happened to this part? So 20e negative 0.21t, the whole thing here will approaching to 0. Because when your t is infinity, meaning that you get your e sorry your the coefficient the index here is become negative infinity, right? It's approaching negative infinity. So e negative infinity will be approaching to 0. When you times 20, is also approaching to 0 as well. So now we try to plus it. So yeah, you have a plus 1, right? So e negative 2.01t plus 1. So this one will be approaching to 1. Okay, then we left with the last part, 1050 divided by the whole thing that you have here. Okay, so you imagine if for the denominator is going to approaching to 1, right? When you use 1050 divided by 1, then you get 1050. Okay, so the whole thing here is n, meaning that your number of people infected will be approaching to 1050. Okay, so that's the idea. So yeah, you just write as in the long run. Okay, number of people infected is 1050. Thus, the whole population or everyone, okay, everyone in the population will get infected. I mean, this is in a theoretical way lah. I mean, in max, but we can't say that if let's say that's, I mean, if let's say like the virus that we have, so if there's someone that always hide in the house and then without interaction with other people, then of course he or she will not get infected, right? So that's the idea. Okay, but this is like in terms of max, it's if everyone like goes like normal, then this is what will happen lah. Follow the rate of change like without any MCO or any lockdown or what. Okay, all right, so that's it. So let's try to look at the very last question. So you must make sure that you can understand this part. All right. Okay, number 5. So this is a very long question. So the population density P of a town can be modeled as a continuous variable. So in the year when records began, the population density P of the town was increasing at the rate of 0.5 people per hectare per year. So the population density of the town was 2 people per hectare. So let us try to write this in max way first. So you don't need to like keep on read like repeat reading the question. So in the year when your records begin, so meaning that is the same when we say that is the term where initially. So that's why when t equals to 0, this is what happened. Okay. So when t equals to 0, the population density was increasing at the rate of 0.5. So meaning that when t equals to 0, the rate of change of population with respect to time is 0.5. Okay, increasing, so that's why it's positive. So at the time when your records begin also, the population density was 2 people, so that's why P equal to 2. Okay, so in these questions, your T refers to years lah, number of years, T years after records begin. So it is suggested that T years after the records begin, the rate of increase of the population density is inversely proportional to the square of the population density. So how can we write that? Yeah, then you should not write it in the same row. So you are not confusing with like this is what happened when t equals to 0 only. Okay, this is like in general t years after records begin. So your dp dt inversely proportional to the square of population density. So inversely proportional meaning you have 1 over, right, the square of population density, so p square. All right. Okay. So now we have finished reading the question. So let's try to look at A. So form a differential equation to model this information. So same thing, we need to form the differential equation. So dp dt will be equal to k over p square, right? Okay, so now we can continue to see, you need to form a differential equation. So I think that you need to get rid of the get rid of the k here as well. So how can you do that? So from the information given, so dp dt is 0.5 when your p is 2, right? So k over 2 square. So which will give you k equals to 2. So now you can write it without any constant anymore. So meaning that it will be equal to dp over dt equal to 2 over p square. Okay, so that's it for A. So now move on to B. Solve the differential equation giving your answer in the form of P equals to f of t. So yeah, I think this is not hard as well. So you can just try to do the uh, integration by yourself. So dp dt equal to 2 over p square. So move the p square. Start your integrate with respect to t. Okay, so now you should be able to continue. So p cubed over 3 equal to 2t plus c. Okay, so same thing, we need an information to substitute for t and p, so you get c. So do you have a set of solution here? So yes, so you have t, when t equals to 0, your p is equals to 2, right? So let's try to substitute. So p equals to 2 when t equals to 0. So you should be able to get your C as 8 over 3. Okay, so now let's try to rewrite the equation. So you have P cubed over 3 equals to 3t plus 8 over 3. Okay, so the questions ask you to actually write this in the form of P equals to f of t. So meaning P is your subject. So we need to just solve this. So P will be equal to, so multiplied by 3, then cube root. So 60 plus 8, the whole thing, cube root. Okay, all right, so that's the B part. So now move on to C. So comment how fit the model is to the actual data in the longer term. Okay, so this is the table that giving you the actual population for every 5 year for the first 20 year. Okay, so you see from C, right? Yeah, I'll try to answer here so you can referring to this table. So from C, we already have our model, which is p equals to 6t plus 8 in cube root. Okay, so meaning that this is the model that we try to do a prediction. So meaning when we substitute 0, then we know that the p is 8. When we substitute 2, then you can get what is your p when t equals to 2. Then so on, I mean t is equals to 5, 20, and so on. So this is the actual data, meaning that we need to see how accurate is our prediction compared to the actual data that we have. So how can we do that? So meaning that we need to substitute every number for us to do the get the prediction. So meaning yeah, I will wish to copy the table here first. So 5 you have 3.5, then 10 you have 4, 15 5.5, and then 20 is 7. Okay, so the P here meaning is the actual population density. So now from the model, we need to find out the prediction. So meaning from the model itself, what is the number that we actually predict? So you substitute your T as 5 and you get your answer. Substitute your 10 inside the T here to get your answer. Substitute your T as 15 to get your answer. And you should be able to get 3.4 4.1, 4.6, and also 5.0. Okay, you should have no problem, right? So just substitute the 5 here for you to get the P, and the P here is your prediction. So now the question wants us to comment on how fit the model is to the actual data in the longer term. So you can realize that actually when you first started, right, the model predicted quite well, meaning that 3.4 and it become 3.5, that's fine, it's like 0.1 only. Same thing here, the difference is just 0.1. But you see, when time goes by, passes by, you can see your 5.5, the predicted one is actually 4.6 only. So for 7, it's 5.0 only. So meaning that every prediction that you are doing is actually lower than what happened in actual. So that's why in the longer term, yeah, so I think the first thing that you can write is the model is not a good fit, right? Because you can see the prediction like went wrong after a few years. So the model is not a good fit. So that's the first thing that you can write. So what is the reasoning, or what is the reason, or what is the explanation that you can try to give? So the model is not a good fit. So the model is, the model is not a good fit. Okay, so you should explain that at the starting is okay, but at the end it's no longer to be okay, right? So in longer term, okay, in longer term, the prediction, or in longer term, the model generates underestimated prediction. The prediction compared to the actual data. Okay, yeah, so I mean you can try to rephrase the whole thing as well lah. Like if you want to say that the model is not a good fit, the values generated from the model is underestimated compared to the actual data in long run. Okay, so the idea is that you need to reason that. So as the time, I mean at the starting is okay, then when go to 50, 20, so what happened is the model actually give you a number that underestimated compared to the actual data. Okay, so that's it for this chapter. So please try out all the questions that you have in the past year paper. So if you have any questions, then we can try to discuss it when we meet each other next week. So that's it for today's lesson. All right, thank you.